Now we come back to this part. So, we have seen how to assign variables. Now, we will see how to do the input and the output statements. So, there are certain keywords in Fortran which allows us to read inputs either from a screen or from a file. So, the Fortran keyword for that is read. Similarly, it also allows us to write something or write the output of a program on the screen. So, a Fortran keyword for that is print. So, here is an example of how to read it. So, for example, from the if I have this line in my program, so read star comma input underscore m, what it will do is once the user types the number on the screen and press enter, the code will read the number and store it in this variable input underscore m. Similarly, when I try to write the output of my program here, which in this case is the length converted into meter. So, I can give a print statement in the following way. So, print star comma and then I put within quotes so this is character array where I just write length in centimeter equals to. So, this tells the user who is seeing the output what is the quantity that I am writing out, and then I give a comma followed by the variable name which gives the results on the screen. So, one thing you note that in both these cases here I have put a star here which denotes that it is written in and read in the free format, but one can also write it or read the data in a formatted form in Fortran, and this is done in the following way. So, typically formats are written after the print statement. So, for example, here I have print and then within this inverted commas and within the bracket I write the format statement. So, for different types of variables one has different ways to write the format statement. So, the first one, so the general form of the format statement for an integer will be written in this. So, the first letter here n denotes how many integer numbers I want to write. The second one I tells me that the numbers which I am going to write on the screen, these are all these are all integers, and then the x tells me the field width the compiler or the program will store to print one such numbers. Similarly, so the format is same for everything, just what will change as we go from integer to character is that instead of I here I use a. Now, it becomes a bit tricky when we go for a floating point operation. So, in the floating point operation the first two parameters remain same. I am still telling the number of variables I want to print on the line, and the second one is I am characterizing it by a floating point real number f does that. Now, in the third category, that is the field width, is now divided into two parts x dot y. So, x tells the total field width for I want to reserve for a given number, and then y tells the code how many characters of the fractional part needs to be printed out of this total x. Similarly, for the real exponential, instead of f I replace here for e. The same principles also applied for the formatted input. So, now we will look into an example of how one writes a formatted output. So, here I have an example program where I am trying to write out a couple of numbers on the screen. The numbers are integers, then they are integers, real numbers, and so on and so forth. So, the way this is done is, so here I have declared a variable I, which I have declared as integer, and I have set it to 1, 2, 3, 4, 5. Similarly, I have a variable j, which I have declared as a real variable, and then I have assigned it to this real number. So, if you look at this real number, so this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, basically it needs 12 places to display in the screen. Okay. Then I have another array variable which consists of 5 such real numbers. That is why I have given the dimension 5. We will learn about array in the later part of this module. So, the print statements, the formatted print statements appeared as follows. The first print statement which I have here tells me that I want to write an integer which will occupy 5 places, and that integer variable name is I. Similarly, for j, which is a real number, so I use this format statement which tells me f is that it is a real number, and then it states me that I want to reserve 10 places for that, and this the number 8 after this dot tells me that I will write 8 places after decimal. So, basically what, if you remember, so this j is to represent this whole number j here, I need 12 places. Instead, here I am just assigning 10 places. So, we will see what happens very soon. Similarly, I write all the arrays of this stored, all the numbers stored in this array V. So, as we have seen here that it has 5 numbers stored. So, I use the following format statement. So, basically first I tell how many numbers I want to print. So, that is 5 tells the code that I have to print 5 numbers. Then I tells that it is a real number with this f, and then I say that for each such number I store 8 places, out of which 3 places are for exponential after decimal. Similarly, I want to write the same number j here as in form of a exponential number, and that is why I have used e in the format statement. Again, I store 10 places for the number, out of which 3 places will be used for the exponential or the fractional part. And we can also write, for example, in the same line real and integer numbers. So, how do we do that? So, this is how the format statement is for that. So, say suppose I first want to write my display the number stored in my variable I, which is an integer variable, and then the number stored in j, which is a real variable. So, in the format statement first I write I5. So, basically what it tells me is that this is an integer and I reserve 5 places for it, and then I give a space here, and then this is followed by the format statement for my real part, which I say it is a f, which I denote by f. I reserve 15 places for it, out of which 8 will be for fractional part. So, what will be the output of this program? So, if I compile and run this program, so this is what I get on the screen. So, the first number here in the screen, that is this 1, 2, 3, 4, 5. So, if we go back to the program, we see that the first print statement is we have asked the code to print the number stored in the integer variable I and for 5 places. So, that is precisely what it has done. Now, the second print statement which was there in the code is I write down the output, the number stored in j, which is, and I use 10 places for that, and out of that 8 will be after the fractionation. And as I told you before that as we counted before, that the number j requires a total of 12 places to print it. So, what the code will do is, so and also I would like to point out here that after the decimal point, so we need 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 places to write down this whole part, fractional part. Okay. But instead we have allocated here 8 places for that same thing. So, what the code will do is it will write what the code will do is it will basically write the code will write the first 8 digits after decimal. So, that is 4, 6, 8. So, till this point, and typically it rounds up after the last decimal place. And this is what we precisely see here in this output statement, which I have taken the screenshot from my laptop. So, I have total 10 places, the number j has been expressed using 10 places, out of which there is 1 place for the decimal point, and then 1 is the part before the decimal, and then 8 places after the decimal. Similarly, if we go back here, so for the array V, we have said that we will write 5 numbers here, and then these are all real numbers, and we replace 3 places after decimal. So, this is precisely what we see here given in this line of the output. And then the second last print statement, where we are trying to write this j in an exponential format. So, what we have is we have stored 3 places for the fractional part. So that is why, so if we take this number, so the fraction in the exponent form, it will read as 0.58938 into 10 to the power 1. So this will be in the exponent form, and since we have kept 3 places after decimal in here to print it, so that is why it is printing 0.589 with a then e to the power 01. And then the final print statement here which we have is a mixture of integers and a fractional number, and that is what the code is printed out. So this is the way we write the print statement in a or write the outputs in on the screen, on the display screen, using a formatted form using the print statement. Now we can also, but this will be very infrequently used, but the most common use of the input output statement is we typically want to write the statement, write the output of the program into files. So what one needs to do is one needs to have several files with some given file names which the user decides or the programmer decides, and then there are some numbers which are associated. These are called typically unit numbers which are associated with a particular file. So the unit numbers for files are issued by using the open keyword. So this open keyword along with the unit number of that particular file tells the Fortran code that we need to open this file with this associated with this particular unit number. And the input output is typically done using the write statement. Remember, when we put it on the screen, we use a print statement, but in the file, to put the output in a file, we use a write statement here. And the read is done by, again, as the read statement we saw. So the format is the same way as the print statement. So for example, write, we use write, then we give the unit number which is my file identifier, then I give my format statement, and then the list of variables. So remember, the number of format statements here and the number of variables here, those things should be matched. Similarly, in the same way, you can use the read statement to read data from a file. So you write read, and within parenthesis you write the unit number here and also the format statement. So this format statement should be in the same format as the data is present in the file which one wants to read in. If there is a mismatch of the format statement, the code typically complains. And then you write the list of variables you want to read in from that particular file. So once you have done with the reading and writing of the file, so what is typically done is one uses this close keyword to close the file. And regarding the unit numbers, so there are two things which one needs to be careful of. So first of all, one shouldn't ever use unit number 5 and 6 to connect the name of the file with that particular unit number. The reason for that is 5 is the default value, unit number equals to 5, that is the default value for reading in from the command line. Similarly, unit number equals to 6 is the default value for printing the output on a screen. So here we have an example of how to write in a formatted way in a input file. So if we look, these variables here are the same, the numbers as in the previous example which we saw, but the difference is in the previous example we are trying to write it on the screen, here we will try to write it on the file. So what do we need to do so? So first of all, we need to have a file, so we need a file name, we need to have a unit number associated with the file, and then we need to ask the code to open the file, then we need to ask the code to write into the file, and then we need to, and then that is the end of the, we need to close the file, and then we come to the end of the program. So how this is done is, so for the unit number we have used integer variable which we have set to the value 7. So basically, and I have the output file, I have given the name as myfile.txt. So as I mentioned in the previous slide, so I asked the compiler to the program to open the file using this open statement. Then after the open statement, I have the unit number. This iostat gives me the status of the file. So iostat typically can take 3 types of variables. So if it is a positive number, so what it tells is that the previous time when we started to read this file, there is some error. IOStat equals to 0 means the previous read has been executed correctly, and IOStat equals to negative means that there is the end of the file has ended. There are no more lines to read. So, basically this variable gives what is the status of the file. So, but this is not so important, and also and then we need to specify the file name. This is done with the file attribute here, this one, file equals to, and then within single inverted commas I give a file name, and then I need to mention that what is the status of the file. Is this a old one which is already there, or is this a new one? So, for that one uses this status statement, and if since we are creating the new file here, so we have assigned it to status equals to new, and we can also tell the code what to do with this particular file. So, that is whether are we interested in reading data from that file or writing data from that file. So, in this case we will be writing data onto the file, and so that we do with this action variable. So, action, so we set action equals to write. So, then this part of the program is where we are writing the data. So, before writing the data, so what we do is we check what is the status of the files. So, if I will come to this if statement here. So, basically what this means is that if this IOStat variable is set to 0, then only we will write, and if it is not set to 0, we will not write anything, and we will print this error message on the screen. If this file is there is no issue with this file, then what it will do is it will write. So, then it will go into this line of the program, the controller, and it will execute this step. So, what it will do is write on. So, this is, as I said, the file unit number, which is equals to 7 here in my case, and we associate this unit number with this file. So, this file is already open with the help of this open statement. The program, the code knows, the computer knows that we need to write. So, it will go to this file containing the unit number 7. It will read in this format statement. So, basically what I am doing is I am writing the variable v here, in the number stored in this array v. So, since as I mentioned in the previous slide that this has 5 numbers. So, I am using a format statement which tells me that tells the code that there are 5 numbers to be printed in this line, and then since these are real numbers, so I am using f, then I am using 5 places for that, and then 1 place after decimal. So, once this statement is executed, then what we need to do is we need to close the file. So, we use the close command and we are done with the job. So, this is how one writes output in a formatted fashion. So, if one wants to read in some data which is already existing in the file, so what one needs to do is one basically needs to replace this write statement with a read statement, and this formatting statement should be the same, should contain the same formatting attributes as those of the data present in the file from which we are going to read. So, with this we come to the end of this first part of this Fortran lecture. So, where we have seen how to read, so what is the typical structure of a Fortran program, and how to end and how to assign different types of variables, how to do mathematical operations, and how to write and read data on the screen and on the file. So, thank you very much.